Hey y'all, today we'll be covering section 6.8, which is about solar energy. The learning objective for today is that you can describe the use of solar energy in power generation and that you can describe the effects of the use of solar energy in power generation on the environment. Some of the essential knowledge that you'll gain is how these solar panels work, some of the ways that we can use active solar versus passive solar energy, and then some of the environmental pros and cons of this method for energy. So first we'll talk about active versus passive solar energy. Passive solar is when we're just going to be absorbing or blocking the heat from the sun. This will not be using any sort of mechanical or electrical equipment. One example of this would be using the sun's heat to cook food in a solar oven, which is something that you can kind of build. It can be made of like plastic, sometimes even cardboard, and you use different tinfoil and stuff, and you basically just use the way that the sun hits it to create heat inside this box, and you can actually use it for cooking. But it doesn't require any sort of mechanical or electrical equipment to work. Another example of this would just be with doing more green building designs. So things like creating your building so that it blocks sunlight in warmer months and allows sunlight in during colder months. Some ways that you can do this are by using things like double paned windows, southern facing windows with a roof overhang, having deciduous shade trees so that in the summer they provide a break from the sun, but in the winter they lose their leaves so the sun can actually warm the house, using skylights, dark colored sunlight absorbing floor, just things like that. All of this is going to be passive, but you can actually design a home in a way that is utilizing the sun's rays when you need it. Now, the other side of this is going to be active solar. And this is where we use mechanical or electrical equipment to capture the sun's heat. We can use things like solar water heaters or concentrated solar thermal CSTs. Or you can convert light rays directly into electricity using PV cells. And basically the way that solar water heaters works is that it captures the sun's heat in water or circulating fluid, and then it transfers that heat to warm water for the home instead of using electricity or gas in order to have a conventional water heater work. So if you look at this diagram, up on the top would be passive. So like I said, having things like using trees for shade, having heavily insulated houses, having thick walls, having vents for hot air to escape in the summer, stuff like that. Versus on the bottom is going to be active, where this person would be using some energy from the sun in order to heat water that can be used for warm water throughout the house. Now, these are going to be photovoltaic cells, PV, or AKA solar panels, as they are typically called. Now, solar panels are going to contain semiconductors, which are usually silicone, that emits low voltage electrical current whenever it's exposed to the sun. So you don't need to be able to fully describe this process for the AP test, but I'm going to briefly walk you through it. Basically what happens if you have the photons, which are the particles carrying energy from the sun. They are going to hit these two semiconductor layers in the solar panel. So you've got an N layer and a P layer. Now, when it hits these two layers, it's going to cause separation of the charges between them. So you're going to have the electrons move in one way and the protons move in the other way. And they're going to go through this circuit load, which is ultimately going to deliver energy in the form of electricity. And so you're going to be able to have this set up. And again, it's because of the separation of charges that's going to ultimately result in these photons being able to create electricity that can be used in a home or any other place. Now, if we have these photovoltaic cells on a roof, they can directly power the building. Or what's a cool benefit of them is you can actually send excess electricity back to the grid for other users. So if you have a certain amount of electricity usage in your house, and if you created more electricity than you use, you can actually give it back to the grid. And most utility companies will give you a credit to pay you for the electricity that you just supplied them with. So it can be a way to even make a little additional money from it. Now, granted, at this point, they are expensive to set up, so it's usually not a money maker, but some places make it actually worth it to where you kind of come out almost even if you're able to make money from this. But it's a benefit that some utility companies use that encourage more people to get solar panels. Now, a drawback of solar panels is going to be intermittency in sunlight. So, solar energy can only be generated during the day, and during certain parts of the year, like during winter around here, you actually don't get that many hours of sunlight. Most of it is going to be where the sun is not shining. So, this is going to be a downside because you need the sunlight in order to make the electricity. Now, this could theoretically be solved with cheaper, larger batteries that can store energy generated during the day for use at night. But at this point, those aren't really cost effective, so it's not something. But maybe in the future, scientists can get it to that point so that we can actually not have this be a downside of using the photovoltaic cells. This diagram, I'm going to briefly explain it, but it's not like super important. But basically, it's kind of the idea that we get what's known as a duck curve when it comes to the production of solar energy versus the usage of when we need it. So if you look at starting at about like 9 o'clock, most people are going off to work. And so they are not needing as much electricity, but this is where the sun starts shining. So the amount of risk that you have for us needing the solar energy compared to how much is going to be produced, it's actually like a really low risk in the middle of the day for us not having enough. However, right around when everyone gets home and the sun goes down, that's when our electricity usage peaks. We now need lights on because the sun's not out. So this is the point where we actually hit a danger of the fact that we are not producing the solar energy, but we need a lot of it. So this is going to be that peak where we do have the risk of us overusing electricity and not having the solar to make up for it. So as I said, it's kind of known as like the duck curve. And it's just a graphical representation of this idea of why intermittency is actually kind of a decent downsize to the idea of using solar panels. So now we'll talk about concentrated solar thermal, CSTs. So this is a way where we could, instead of having solar panels on everybody's house, this could be a different method for us. So this is where you're going to use heliostats, which are basically big mirrors. They're going to reflect the sun's rays into a central water tower. This central water tower is going to heat up water in order to do this typical process we've learned about a few times, where you create steam, which is going to power a generator, or a turbine, which is going to power a generator, which is going to power electricity. Hopefully by now you've kind of got that system of energy production. But anyway, you're able to use this and concentrate it so that you can actually create electricity from these concentrated solar thermal areas. Now, a big downside is habitat destruction. Granted, these often are actually built in the desert, so it's not like we're cutting down a ton of forests, but the desert is still somebody's habitat, and we are going to displace the organisms that live there. And so habitat destruction will be occurring in order to make these. Now, another thing that can actually happen from these is the light beams from the mirrors all being like so concentrated in one area actually can be so powerful that they can fry birds in midair. So that can also be a downside for the bird population. It's not like a massive amount of birds, so it's not like the hugest downside, but it is a downside for the birds that get fried by this. So this is going to be kind of a bit of how this works. So as you have the heliostats, they're going to direct all of the light energy to a central point. Now you've got this solar receiver on top of the water tower, and that's usually going to be filled with some sort of like salt concentration, like salt water thing that can actually hold a lot more heat than water. And then that's going to go into like the boiler area, which is where we get to our typical cycle of you make steam, which turns a turbine, which goes to a generator, which is going to make electricity. And that's how these things step by step are going to work. Now, this is going to be the idea of community solar farms versus rooftop solar. So a pro tip on the FRQ, don't just say solar panels. You should try to differentiate between rooftop solar, which is where you have individual homes and businesses with a solar panel on top, or community larger scale solar farms. So the difference would be in this picture here. If you have them on top of houses versus if you have to go into an area and destruct the whole area to build these farms. So you just want to make kind of that distinction when you're talking about them on an FRQ. Now, the large scale solar farms are going to be awesome because they can generate a lot of electricity, and typically we put them in areas like deserts that have a lot of sun. But the downside is they do take up land and they're going to cause habitat loss and habitat fragmentation. Now, rooftop solar is awesome because it doesn't take up land, but it doesn't produce as much electricity, so that's a bit of a downside. So just kind of be aware that there is a difference between the two, and you want to be specific if you're talking about them in an FRQ. Now, there are pros and cons to solar energy, and we're going to go through both of them. So the pros of solar energy, first of all, there are no air pollutants from this during our electricity generation. So we don't have any carbon dioxide release when we're generating electricity. We don't have particulate matter. So overall, the air's a better place. However, sorry, I won't get to the cons yet. I'll keep going. So another benefit is going to be that we don't have to go and mine fossil fuels, which we've learned about all the downsides that can happen environmentally with that mining process. And another benefit is that it is renewable, unlike fossil fuels, which can run out. The sun is never running out. If it does, we have a much bigger problem than our electricity grid. So it is renewable. We can keep getting it. Now, some of the cons of solar energy. First of all, the semiconductor metals, such as silicon, do still need to be mined in order to produce those solar panels. So we're still going to have some of the mining downsides, such as habitat disruption, water pollution, problems from like the mine tailings that can get into local waterways. We have particulate matter in the air from all of the like tractors and mining products. And also silicone is a limited resource, so eventually it can run out. And as I talked about a couple times in these notes, solar panel farms can displace habitats and cause habitat fragmentation. So that is going to be another downside to them. So for practice FRQ 6.8, I want you to look at this diagram, and this is going to be practicing data analysis. So I want you to explain the relationship between the tracking ability of a solar voltaic system and its energy production. So you can look here. This is on the bottom going to show you how the system is going to be tracking. And then up on the top is where you're going to be looking at the energy production at different times of the year. And so make sure that you pay attention to the colors of like the dual axis tracking versus a single axis tracking versus no tracking, etc. So you're going to explain the relationship between the tracking ability and its energy production. So some of these examples, they don't track. Some of them track in one way. Some of them can track all over the place. So explain this relationship by looking at this data here. All right, so that's going to be your practice FRQ for 6.8, and those are your notes on 6.8 about solar energy.